Why the hell would we want to go to Mars? Why the hell would we want to go to a planet that is totally uninhabitable? It's very far away. Probably we will die on the way there. It's a lot of resources and money that is just wasted. If you're new here, this is part 3 of a 5-part series where we look at a blog post series from Team Urban of Wait But Why. It's from 2015, and he back then looked at all the different ventures of Elon Musk and of the companies Tesla, SpaceX and Neuralink, and also how Elon Musk thinks and how he acts in his companies, why he's so successful. So let's look at SpaceX. Team Urban divided this blog post into 3 parts. First part is a bit of context, so it's a bit of history of space and humans in general. Then the second part is why would anyone care about space, about the Mars? And then the third part is if we care about Mars, how could we get to Mars? So we start with part 1, the story of humans and space. He begins by explaining that around 6 million years ago, a process started and humans started to wake up. They started to ask questions like, where are we? First they thought it's a flat object, then they found out it's actually round. And then as humans started to build the first cities around 10,000 years ago, they also found out that actually the sun is not revolving around us, but we are revolving around the sun. And even worse, not even the sun is the center of things, but the sun is just one little part of a very big universe. But then it got even worse, and we found out that even that is just surrounded by a big mess of nothingness. And he said that's why most of us are just living like this guy in some sort of la-la land to avoid those really big existential questions. But then during World War II, the missile technology had a big leap, and suddenly a new concept was possible, which is space travel. In the following years, the Soviets were the first ones to put something into space, which was the Sputnik 1. And then a few years later, they also were the first ones to put a person into space. The first person in space was Yuri Gagarin in 1961. And this put a lot of pressure on USA. And 1 month later, they also put a person into space. That person was the American astronaut Alan Shepard. Then during the next 7 years, the US and the Soviets had a full-blown space race, and they sent 22 manned launches. Over the next years, the US and the Soviets had multiple launches into space. And then in 1969, the Apollo 11 made Neil Armstrong and Buzz Aldrin the first people on the moon. Neil Armstrong was the first person, but only a few minutes later, also Buzz Aldrin stepped on the moon. And then this iconic photo is actually of Buzz Aldrin. But then only 3 years later, in 1972, was the last time someone actually went to the moon. By the time of this blog post, it was 32 years later where no person went back to the moon. I think this quote here sums it up quite well. People from 1972 would be blown away by our smartphones and our internet, but they'd be just as shocked that we gave up on pushing our boundaries in space. So why did we stop that? Well, he says that just like in the Tesla post, that's the wrong question to ask. The right question is to ask why we ever were adventurous about sending someone to space. So he says that there are 2 primary reasons why we would ever go to space. The first category is support for Earth industries, and this is mostly about satellites. It's a very interesting blue box, so I would recommend you guys read it. Basically, he says that satellites help to navigate on Earth, but also it's used for communication and weather forecasting, television, photography, and some other stuff. And then category number 2 is looking and learning. This category consists of basically 2 things: sending probes into space and sending telescopes into space. And both of them have the goal of advancing our scientific understanding of the universe, about materials, about physics, about chemistry, and so on. He goes into detail into a lot of robots we sent into space. I don't want to go into all of this because otherwise this would escalate into a 2-hour-long video. But feel free to go into it, and we will continue with the ISS. The ISS is a very cool international collaboration. It's about the size of a football field, weighs over 400 tons and is more than 100 meters wide. And the main purpose of this is to have a space science lab. So coming to the end of this part 1, he describes that the space excitement in the first years went up like crazy, but then in reality it came down a lot, and now it has been quite stagnant. And he compares it to a magician that does the craziest trick at the beginning, And then it keeps on getting smaller and smaller, and at the end, it's not interesting anymore because he started with the craziest trick. So going into space and going into the moon and everything was the crazy trick at the beginning. But then the adventure part of all of this was falling down and going to zero, basically. But the scientific, the discovery part of all of this still went on, and we still learned a lot more about the universe, and we sent probes and telescopes and everything into space. So he basically says that in the last decades, the discovery part of space was still very active and alive, but the adventure part was kind of slowing down and dying. And so with this, let's get into the question of why is this even relevant? Why is space relevant? Why is Mars relevant? Why would it be interesting at all? To answer this question, Tim proposes a thought experiment. He introduces two aliens from a very far civilization that is very advanced technologically, and they are called Serpel and Quickney. And they are both watching Earth and seeing the development. And then they make a bet, because it's what they like to do in their free time. They bet on if the civilization will survive or not. And Serpel is betting on humanity, and Quickney is betting against humanity. Quickney might seem very pessimistic, but actually he has some data to back his claims. So he's looking at the extinction events of the last 500 million years on Earth. And Tim highlighted here the 5 biggest extinction events. The last one is also where the dinosaurs died. And Tim argues that humanity has never seen a mass extinction event, and that if something like this happens, there's a pretty big probability that all humans might die. Then he goes on to list a lot of extinction events that could wipe out the whole of humanity, and I will just name a few. Supernova, gamma ray burst, solar flare, magnetic field change, black hole, aliens, global pandemic, asteroids. So there's quite a variety of reasons why humanity could die. To the topic of asteroids, he made a blue box where he went into it further. I won't go into everything, but this graphic I think is quite crazy. If you look at the red dot, there's a little dot in the middle, and this is the size of the asteroid that hit Earth when all the dinosaurs died. So you cannot even really see it, and it wiped out all dinosaurs. Now, if you have a bit of an uncomfortable feeling, maybe this quote will make it a bit worse. The mass extinction event graph above tells 5 horror stories from the past, when our quiet Earth became the setting for an unspeakable nightmare for everything that lived here at the time. And it will happen again, right here where you sit. The only question is when. Now, to illustrate that point and to make it a bit more understandable, Tim poses another thought experiment or a comparison. He says that we can assume, just for the argument's sake, that in the next 50 million years, one of these mass extinction events will happen. Then it's a 1 in 50,000 chance that this will happen in the next 1,000 years. And then he says proportionally, it's kind of the same as if you would draw a circle on the ground and you would say, on this circle, in the next month, there will be a lightning strike. And the 1,000 years is basically like 1 minute on this spot. So you have to stand there for 1 minute on this spot, knowing that in the next month, at some point, there will be a lightning strike. So he says that it's not very likely that you will get hit, but it's also not really comfortable to be in this spot. Then he makes another comparison. He stays with the timeline that 50 million years is 1 month for us. And he says that the whole universe, everything that exists, is on a hard drive. Then on this hard drive, the Excel files on this hard drive are the different species on Earth. And in these Excel files, there are like trillion rows of data and everything about this species. And then he says, right now it's August of 2015, so when the blog post came out. The hard drive itself was created or came into existence around 8 years ago. Around 1 year ago, the first Excel files were uploaded into this hard drive. And since then, the hard drive crashed 5 times, and sometimes like 70% and 90% of all the Excel files were just deleted in this crash. And he says that right now it's mid-August in 2015, and the whole Homo sapiens Excel doc was just created 2 hours ago. And then he says, now, if you own the hard drive with an extraordinarily important Excel doc on it, and you knew that the hard drive pretty reliably tended to crash every month or 2, with the last crash happening 5 weeks ago, what's the very obvious thing you'd do? You'd copy the document onto a second hard drive. That's why Elon Musk wants to put 1 million people on Mars. He wants the people on Mars to be completely self-sustaining, And Musk calls it life insurance, and Tim calls it backing up the hard drive. And then Tim says maybe it's not enough to have one backup. Maybe if it's so important, you would have a few backups. And then he goes on to describe all the different planets and why Mars is just the obvious and best option for us all to have that backup. And also he says that right now is a moment in time where a lot of things come together and there's a lot of improvements and a lot of things happening. And he says that maybe right now is a good time to back up the hard drive. He says, I quote, "Maybe there's a good reason to believe that we're living in the upswing of an exponential curve of progress, unlike any that life has ever experienced. And since with progress comes power, our species now has an unprecedented amount of power to influence things." And he says that's also why the two aliens introduced earlier, Serpil and Quickney, they are so locked in right now on Earth, because right now is the do or die moment. Right now is the decision time. And he argues that right now is the best moment to back up our hard drive. Now, I cannot go into everything in this post because it's quite long, but I really recommend you guys read it. It's very nicely made and it's so illustrative. I have another quote here. It's not only Musk that thinks like this. Also, Stephen Hawking has said, "Don't think the human race will survive the next 1,000 years unless we spread into space. We need to expand our horizons beyond planet Earth if we are to have a long-term future spreading out into space and to other stars, so a disaster on Earth would not mean the end of the human race. Once we spread out into space and establish independent colonies, our future should be safe." So that's why Musk decided this is a real issue and this is really important for humanity. First, he wanted to make a little probe, a little plant on Mars to spur the motivation and the enthusiasm of Mars and of space. But then when he looked into the details of how to get to Mars and which rockets to use, etc., he had a little trip to Russia, which was not good at all, where he wanted to buy the rockets. But in the end, he decided to do it himself. And not the planned project, but the big project. He believed it was possible and he wanted to put 1 million people on Mars. In the next section, we look at how that could be possible. Right, then we come to the last part 3, and here it's all about the how. How is it possible to go from point A, where there's 0 people on Mars, to point B, where there's 1 million people on Mars? First thing Tim says is there needs to be 2 things, a will and a way. And Elon Musk believes that if he provides a way, then the will follow automatically. Now, to provide that way, there needs to be a big enough intersection of people who can afford to go to Mars and who want to go to Mars. That's a green area here in the middle. And that's supposed to be at least 1 million people. Tim says the problem is right now it looks like this. And for this to happen, Elon Musk's goal is to bring down the cost of one ticket to Mars to under $500,000. So Musk put together a team and they basically came up with that business plan here. Going from point A, where there's 0 people on Mars, to point B, where there's 1 million people on Mars. Basically 3 phases. The first phase is to figure out how to put things into space. Then here they launch something into orbit. And from there on, the plan is to have an ongoing business in the space delivery environment. This is phase 2. And then in phase 3 starts when the ticket to Mars is down to $500,000. And from then on, it's an ongoing process where more and more people come to Mars, and in the end, there's 1 million people there. And these 3 phases here are also how the rest of the post is divided in these sections. I named them phase 1 is learn rocket science, phase 2 is lower costs, and phase 3 is build a sustainable city. So let's start with phase 1. How the hell do you build a rocket if you have no idea how to do it? Well, Musk read a lot, he asked a lot of questions, and then he also surrounded himself with excellent, smart people, and SpaceX was born. One of the first employees was Tom Müller, a renowned rocket engineer, and this guy then also began to hire new people. They had 2 really important hiring policies. First is no assholes, and then the second one, talent is more important than experience. So it doesn't really matter what degree you have, but it matters what you're capable of. And there are also a lot of examples from people that started at the bottom of the company without any degrees, and now they are top managers because they just do great work. And Musk was also very much involved in this process. For the first 8 years, he almost did every single interview himself. until they had around 1,000 employees. A big reason of why SpaceX even had a chance of succeeding is that the factory, just like Tesla, was designed from the beginning to be very vertically integrated. Ashley Vance, who wrote an early bio of Elon Musk, explains it like this. The factory is a temple devoted to what SpaceX sees as its major weapon in the rocket building game, in-house manufacturing. SpaceX manufactures between 80 and 90% of its rockets, engines, electronics, and designs its own motherboards and circuits, sensors to detect vibrations, flight computers, and solar panels. He then goes on to say that this vertical integration is a lot of work, but that's also how other companies like Ford and Apple were able to be that successful, because they could control every single part of the manufacturing process. Another big reason why SpaceX had a chance of succeeding, and yeah, this is maybe obvious for fanboys of Musk, and probably cringe and just a fanboy thing to say for people that don't like Elon Musk. But Elon Musk just knows a lot of things and is just very smart. Okay, Tim goes on to describe a bit of the history of rockets and rocket design. And then the first big rocket of SpaceX should be the Falcon 1. Its primary goal was to lower the costs of rockets by a lot. Tim describes that the reason why rockets were so expensive before that is that the companies that are producing that are huge companies and they don't take too much risk and that they don't really have vertical integration. But SpaceX didn't have any burden of a big company, so they were able to build and design the new rocket from scratch. So they started it with the money that Elon Musk made with PayPal. 70 million of his money he put into Tesla, and that left around 100 million for SpaceX. The story is now already quite famous, but Musk said that it will be enough for 3 or 4 launches. And famously, the first 3 launches were a big failure, but then the 4th one actually survived and was a good success. Tim then goes on to nerd out again. It's very interesting, but I will not go into it right now. He describes what an orbit is and why most people don't really understand how rockets work. And then he said, yeah, first 3 times failures, and they were caused by really tiny things. Like, for example, one time it was just one corroded nut that caused the whole thing to explode. But as already mentioned, the 4th time was a big success. They nailed it and they were able to make it way cheaper than other options, like 3 times as cheap. And that's also the reason why in the end SpaceX got a 1.6 billion contract with NASA to deliver 12 payloads to the International Space Station. Okay, so if we look at the business plan again here, now we arrived in phase 2. Because the milestone here was to launch something into orbit, and that has been achieved now. After that success, they took all their learnings and designed a new, really big rocket from scratch, and it's called the Falcon 9. It's a massive rocket that is like 68 meters tall. It would be a 20-story building, if you would compare it to a house. And it was, at the time, the most advanced rocket ever made. Here is a good picture that puts it in perspective. If you look at all the rockets that ever were created and sort them from small to big, Falcon 1 was quite at the beginning. The Falcon 9 is one of the biggest rockets ever. Tim then goes on to describe the different stages of a rocket. It's also quite interesting, but I won't go into that now. And he explains how a rocket engine works. I think it's quite interesting because it doesn't work like a propeller, because the propeller needs air to push against to move itself forward, but the rocket engine is basically like an explosion in the chamber where the gas can only move out in one direction, and that's why it kind of pushes against itself, so it also works in vacuum. It doesn't need air to push against it. And the engine that SpaceX developed for the Falcon 9 was the Merlin. 9 of those worked together to push the rocket into orbit, and already 3 minutes after the start, the first stage separates from the second stage, and the second stage here with the payload or with the people inside. After 3 minutes, the first stage gets separated from the second stage and the payload, which you can see here on the right, because the first stage is empty and the second one is filled with fuel. And now this one continues with only one engine. And with this engine, the second stage and the payload gets propelled to their exact location in space. And in the payload, you can either have things like satellites, or you can have people, for example, going to the ISS. Then he goes on to describe more the development process of the Falcon 9. And then the Dragon, that is the capsule with people in it. And how there were some issues, like the 20th launch was not successful, but in total it was quite successful. He describes quite well why spaceflight is hard. It's really interesting to read, but it would be too much for this video. Tim goes on to describe that not everyone is happy about this innovation and about this cost reduction. And the two main players in this are the Russians and the ULA, the United Launch Alliance, and it's a joint venture of Boeing and Lockheed. Those are the old players that can be disrupted by the innovations of SpaceX. But yeah, as we know today, they couldn't really do much to stop that innovation. Then Tim goes on to describe what is in the pipeline for SpaceX, which back then in 2015 was very exciting. And in a moment, I will compare it to today. So the first one is Falcon Heavy, which is a massive rocket. Then putting way more satellites into orbit with Starlink, and manned space travel. So with the Dragon capsule, the plan was to bring people into space. And as you can imagine, today all of these three are very successful. Starlink is fully operational with over 6,000 satellites. The Dragon has been sending people to space since 2020. And the Falcon Heavy has completed several successful launches and is now even being superseded by the even larger Starship. What you can see here, by the way, is the Dragon 1, and the Dragon 2 was even way more advanced. Okay, now that was a lot of information, but if you can remember this chart, that was actually the goal. To bring down the cost of spaceflight so much that a ticket to Mars would be less than $500,000. So how could that be possible? Well, first by building an even larger rocket. Back then they called it the Mass Colonial Transporter. Today it's called the Starship. They can bring down the cost even more. And then actually most importantly, reusability is necessary. Today we know that they have succeeded with this already, but back then it was very unsure and it was kind of a crazy thing to do. I have another quote here. Popular mechanics calls it a tense juggling act where any of thousands of moving parts can push the entire system into mayhem. If the rocket does land softly on the barge, it's because millions of insanely detailed self-adjustments have kept the Falcon 9's composure as it dove through chaos. Yeah, when Tim first published this post, they didn't succeed yet with this, but then he made an update and linked also a video of the first successful landing. And I really recommend you guys look at that. It's very exciting to see, very motivating. Especially here at the time of 31 minutes, it's very cool to see. So that's the theory behind how it's possible to go to Mars. It's still far away, even today. It doesn't seem like it would be in the next years. But yeah, now let's look at Mars. How to colonize Mars. So phase 3, how to build a sustainable city on Mars. Let's look again at the business plan. The 3 phases. Phase 1 was marked by Falcon 1 and Falcon 9. Phase 2 is right now being marked by Falcon Heavy, and then phase 3 will need the Starship. Now this last phase, I have to say, is a bit over-enthusiastic maybe, and I think for a lot of people this will be too much, but keep with me for a second. Now we have this graph again, and by now we kind of established how it would be possible to afford going to Mars, but actually why would anyone want to go to Mars? Tim makes a calculation. He says that if today around 8 billion people live, and there will be around 20 billion people be living in the 21st century, then if you calculate it, around every 20,000th person would want to go to Mars and can afford it. And he describes that at the beginning it will be very expensive and very difficult and crazy to go, but it will be more and more normal over time. And at some point it will be really exciting for people to go. He writes, there will be lots of interesting opportunities for anyone who wants to create anything new, from the first pizza joint to the first iron ore refinery to the first of everything. This is going to be a really exciting thing for people who want to be part of creating a civilization. Yeah, quite crazy. What do you guys think? Would you guys be interested in that? I'm not sure about it. But anyway, he says that at one point there will be 1 million people, and then it will be at point B. And for a lot of people, this will seem like a completely unnecessary thing to do. But Tim says that it's like someone says, I'll worry about my health later when I don't have so many bills to pay. There will always be important problems to address on Earth, but if we allow what's urgent here to prevent us from addressing what's important in the big picture, we are allowing ourselves to take a huge existential risk. And lastly, Tim also writes that a big reason to go to Mars is also to have a really exciting thing for humanity, something that unites us as a human species. So if we assume that people really go to Mars, how would that look like there? I mean, at the beginning, probably it would be very precarious to live on Mars. Eventually, maybe we could build a bubble like this, and inside the bubble there's an earthly atmosphere. But over the long term, it might be possible actually to make the atmosphere breathable just like this, like over the next hundreds and thousands of years through, for example, with nukes and with greenhouse gases, we could actually make the air breathable. So Mars could look like this over the next 100 or thousands of years and could look like Earth at some point. So this picture, maybe in 5,000 years, you wouldn't know if this is on Earth or on Mars. Yeah, and then Tim goes completely crazy and says that if we have Mars, then we can also go to other planets and we can inhabit basically the whole solar system and at some point maybe even become a multi-solar civilization. And then he says with enough time, humans in different solar systems will no longer be the same species. And to round up all of this craziness, I will leave you with a quote. The light of consciousness that flickered on millions of years in the past on humble little Earth will spread throughout the galaxy and into other galaxies, branching into thousands of different life forms. Most beings in the lineage will be hazy on where it all started, but those who know the history will be able to tell you all about the Great Leap, that pinnacle moment in antiquity when their primitive ancestors emerged from the womb and became conquerors. And with that crazy quote, see you next time when we talk about Elon Musk, his way of working, and his systems that he's building. Bye-bye.